Welcome to our videos for Chapter 29. This is our second chapter on chemical kinetics, where we will be looking at reaction mechanisms. So in Chapter 28, we looked at rate laws and the empirical observations we have of what are the rates of reactions. We can measure how fast reactions happen as a function of concentration to figure out rate laws. And also at the end of the chapter, we talked about how do rates depend on temperature. In this chapter, we are going to look, instead of just at these quantitative ways of measuring rates, we want to get more into the how do reactions occur. What is the mechanism by which a reaction happens? And so that is really the thrust of this chapter. So to describe how reactions occur, we describe what we call a reaction mechanism. And what a reaction mechanism is, it's a series of elementary steps, single reactions that happen that sort of build up to the overall reaction that we have. We'll look at some specific examples of this and how we can, from a reaction mechanism, derive what we would expect the rate law to look like for a reaction. So a reaction mechanism is a series of elementary steps. So let's explore this idea, like, what do I mean by an elementary step for a reaction? So generally for many reactions, if not all of them, there are probably some exceptions, but for most reactions, we start with our reactants, but they don't immediately turn into products as the reaction occurs. We form some sort of intermediate, and you're probably familiar with this idea already from organic chemistry, thinking about reaction intermediates and trying to predict what products you'll get from mixing two particular things. The same thing happens not just in organic reactions, but this is generally true for any sort of chemical reaction we can come up with, that usually there is some sort of intermediate in between coming from your reactants to your products. So let's illustrate this by an example. Let's say we're looking at a gas phase reaction of NO2 with carbon monoxide. And the overall, we have an observed rate constant that'll go for this reaction, we'll call K observed. Overall, the reaction leads to the formation of NO gas and CO2 gas. Now, that doesn't all happen in one step, so we'll call this reaction 1. This reaction 1 takes place with two elementary steps. So the first step is that NO2 collides with another NO2 molecule. So you actually have no carbon monoxide involved in this step at all. And this has some rate constant for step 1, called K1. And this forms NO3 and NO. And then the NO3 goes on in a second step to collide and react with carbon monoxide. And this second step has its own rate constant that goes with it to form NO2 gas and then our final product of CO2. So we can call these reaction 2 and reaction 3. So reaction 1, this is what we would call the complex reaction, or this is what you would normally write out when you write out a reaction equation, like what are the reactants, then become the products. And steps 2 and 3 are what we call the mechanism that is made up of elementary steps. So this is the reaction mechanism with two different elementary steps. Now, one thing we'll do with notation-wise, and so I'll sort of replace it in this particular example. For a complex reaction, we usually just use a single arrow, like our usual thing that we have here. Let me just highlight it with orange here. Right, this is sort of our normal notation here. But for a elementary step, instead of writing it with this single arrow like this, to designate it as being different than a complex reaction, we'll write it with two lines like this. So this notation is what we use for elementary steps in a reaction. And for these elementary steps, we can classify them into sort of three different types. So the types that are shown here, these are bimolecular elementary steps. And this is just based on how many reactants are part of that elementary step. So you can have a unimolecular step, which is just some product decomposing into something, or some reactant decomposing into some products without anything else happening, right? So there's no other reactant that's present. You can have a bimolecular, which is one of the more common ways of an elementary step happening, where you have two different things, or it could even be two of the same thing, colliding, and that reaction forms products of some kind. And the third option is termolecular. So that's where you have three things colliding to form products. So, you can see in the prefixes here, this is where we say like 1, 2, or 3, how many are reacting. These are termolecular, this is uncommon because it's very unlikely. It's pretty rare for three things to collide unless pressure is really, really high. So these are pretty rare events that you'd have three things colliding, and so any reactions that rely on a termolecular elementary step are really slow. And there are no known elementary steps that have 4 or more things colliding. So this is right. This is it, because if 3 is hard, 4 is basically impossible. So that's our introduction to reaction mechanisms, and we will continue this discussion in the next video, looking at how we can go from a reaction mechanism and how that can help us figure out what the rate law is for a reaction if we do understand how that reaction occurs.